All right, let's go ahead and check out another open source project. Last time we looked at what was this one? The development of the robot arm, and kind of saw that that was the ideal, what I would say, ideal way of setting up a bomb bill of materials to have all of the components kind of locked into their subassemblies. So to have it in subassemblies and make it very logical for a build house or for kits or for manufacturing to be able to figure out how to assemble it and to segment the bomb by kitting up the bomb to allowing you to find these parts very easily and be able to build each subcomponent easily and then integrate them together by however you decide to segment the different portions of the subassemblies where you have one stop and one end. Okay, here we go. Here's the Voron 0.1. This is not the latest version. I think they're on 0.2. I have one of these Voron 0.2s, and now it doesn't have this assembly like this. It's now square. It's got a square cap on it, and so it has another rail here with the lock segment. So I'm going to use the mouse in my right hand, and I'm using a 3D space mouse on from 3D Connections on my left hand. So let's go ahead and go over this. Pretty funny, they got a banana in here to kind of go over, kind of show the size. Very, very small printer for a comparison. Obviously, you can go up here and inspect. I think it's only like 6 inches wide by 6 inches wide by maybe a foot tall or something like that. So let's go ahead and look at how they do the kind of the bomb and compared to like that robot arm, right? So the robot arm, it has component by component. So here it looks like they're kind of doing a mix. So here we have the frame components. Now it is true general. So this is a kit, and so they have instructions. The instructions for the kit is very, very well done. I would say that this is one of the instruction manuals that you can use as a guideline to develop your own user manual for either built in manufacturing or or however you want to do it. So obviously for manufacturing, you're going to need to have some sort of procedure that is locked in with all the specification, torque values, dimensions, all these things that need to be correct, as well as testing. So did it pass QA, quality assurance? Did it pass that QA testing to be certified to, hey, this is most likely going to work? And then that way, when you ship it, the chances of you having problems coming up is way less likely. So, how you build it is generally you build it by the frame, including these rails. So, this is kind of step one, which is interesting on the build. And I've built mine fully, haven't got it up yet because, again, I have a zero point 0.2 because I believe the hot end was bad, and so it died kind of instantly. So, these components are generally built first, the frame, and then this back section in here is built before you close it in. So generally the frame and the gantry. And I think also the gantry is kind of built separately. Another thing also that's built in here is, if you see this bolted here, is the Z gantry. So I think here Z gantry is there. And then you have the Z bed, or this is the Z gantry. So, and then the limit switch is up here. I think the limit switch on mine's in the bed. I can't remember. But I have the sheet metal bed, not the aluminum extrusion bed, the upgraded bed. So basically how they have this built is in the sub-assemblies. So it doesn't look the same as the arm because these things are kind of inside each other, while the robot arm is the easiest to see because it has these different links that are sequential, right? Arm 1, joint 2, joint 3, joint 4. There you go. This one is a little bit more complex, but you'll actually find. Let me actually get the manual real quick. So we're going to go printers, Voron 0, and let's go ahead and again, Voron 0.2. I downloaded this a long time ago. So let's go ahead and look and see kind of how their subassemblies work. So again, this is a very, very good reference. Voron's website is here. You can see vorondesign.com. So here it has all the things, and you see here initially the very first thing, again, this is 0.2. What we have there in the video is a 0.1. So it's showing you kind of the subassemblies that you're going to build. So you see here you're building the frame first, and then you're building the z-axis. Now some of these are going to be the same between again, I had the sheet metal version, not this version, but a lot of these are going to be the same between version 1 and version 2. But you see here they're building the first two sub-assemblies. One is the frame and the next one's a Z bed. Now they're kind of building them at the same time. So you see here they built the Z bed first, and then they're adding this kind of horizontal portion, right, of the frame. So those are the two different parts that are interacting with each other. So maybe that should have been counted as the z-axis. So maybe that should have been the z-bed. And so there you go. Now you have a nice, good separation. Because now they're going right. So this is the one I have, the Kurigami sheet metal, this one. So now they're going directly into the z-bed sequentially. So you see the BOM is sequential to the actual assembly. And there was that one part that I don't agree with. This part shouldn't have been part of the frame. I think that should have been part of the Z bed, same as on the bottom. So you saw there, if I highlight the frame, the bottom there. So I think that should have been there. Just obviously they're doing this just to call it that. So I guess it depends on how you want to segment it. If it is an open source project, this is probably better for the user to understand by doing it this way. If it was me, I probably would have combined. If it was an open source project and it was just your team seeing it, and it was used, this model is only to be circulated internally, confidential, then I would have had this. I mean, here you go, right here. This is the Z frame. Frame, Z axis. There you go. The two parts are here. So it should have probably been that way, right? I mean, here's all the parts for the z-axis, and then he's adding the frame to it. So anyways, but it makes more sense that people don't get confused when they say, okay, I click on the frame, it's not all the frame. I guess also how they named it, maybe come up with a different name for that. But the z-axis, maybe you call this XY axis frame, or in this case, it's only the Y. This is the gantry. The gantry is the X, and then also the gantry is there. It should have probably been this way, and I can. There you go. Now I fixed it. So frame, z-axis. Oh, they have the bed. The bed is a separate section. Okay. I mean, if you want to do it that way, then that counts. That's a way to get out of it. So, okay, this is literally the Z frame, all the framing, and then the Z bed. Okay, so that makes sense. So he added the Z bed on there, and then now he's starting to add some of the paneling. So the paneling is here in its own kit, but you see it's kind of assembled in different segments. But we can check on the gantry, and it looks like all of the screws, so you can see a screw in here, you can see screws down here, flathead screws. So all the screws aren't in their own kit, they're inside the general kit of all the big sub-assemblies. So that's good. You see here putting in the paneling, and then also putting in all of the nuts inside of the aluminum extrusion to keep it. Finish building the frame, and then you start building the gantry. So here you start adding the gantry onto the frame. The XY Core XY motors here. It's taking the Core XY motors and adding them in. This is 0.2, so you can see it's starting to diverge. The design is a little different from what we have. You can see here it designs different motor on the bottom. So here starting to add the motor, starting to add the Z-axis motor, and all of these different components. Here's the bottom foot. So here's adding the feet to it, and then also the limit switch for the filament run out and all the caps and things like this, and then dropping the Z-axis motor in, and then the alignment screw, anti-backlash nut, and checking to make sure that at the top and the bottom does bind up. And then here starting to build more of the gantry. So you see here it is kind of going down this segment. Now I moved the Z bed in front of the gantry, and you saw one of the portions that they did is they put this panel in kind of before everything else, which is this panel here at the bottom. And I think it's the same here. Again, this is 0.1 versus version 0.1 versus version 0.2, but I think it's the same for both. And then here you can see the hardware, and we saw that that's all in one kit. And then here you can see still going through the rest of the gantry design. Okay, gantry bed, everything is there. And then here's for the actual heated bed, which is inside of that Z bed. So you're kind of going back and forth between Z bed, gantry, all of these ones. But again, it's better to have it in order. Also, open source kit, people look back to see, hey, which ones do I have? They like to kind of be in sequential order there. It makes it easier to check the general assembly. This looks like Fusion, probably. And again, this is a Fusion file, so I believe they did all the design in Fusion 360. Okay, so they're finishing up the hot end. And the pocket watch thing, I think, is an old thing. They don't have that anymore. I don't even really know what it is. I mean, it's some sort of Bowden system, I believe. Anyways, I don't think they're using that anymore. I didn't have it. So gantry also includes the was a stealth burner or something, the name of the hot end. So all of that is included in the gantry. So they're still doing the gantry here. Okay, so now they get to the electronics. Oh, hey, look at that. Electronics is next one, sequential. Very good. Electronics is there. Pocket watch not used. Skirts on the bottom, spool holder, panels, top hat, and then, of course, the banana. So I think the rest of this is in sequential. So basically, they're installing the paneling. Some of the paneling's already there. And then now they're installing the cooling fans and the electronics, wiring, all that stuff, putting in stuff for the power supply, everything on the back, the motors, controlling the motors, thermoresistor, all of these things, the caps. And they have these little random drawings. Then they're starting to add the skirts and side panels. So you can see the spool. I think the spool is already there, maybe not yet. So spool holder, panels, top hat, and then the skirts. So it's basically, for the most part, sequential. So everything here is sequential. Here's the spool holder. So they did the skirts before the spool holder, so you see that's sequential. And then they start to put together the Bowden equipment, put some of the paneling, put more of the paneling on. Put the slip hinge on. I never did do the paneling nor the top hat on mine because I couldn't get mine to fire up yet. So these are parts that are still pending. Anyways, so as you can see, great manual, and I would say this is a B plus or A minus assembly here. Pretty much everything is in order. All the screws are in the different sub assemblies. So, and you can see it's a very, very flat bomb. So this is a kitted bomb. So it's not piece parted in. So it's a very, very small bomb. But if you go in here, you'll find these things are massive, right? and this is kind of how you want to have it. So when you go in and you create a spreadsheet of this for a bill of materials, you can have it by subcomponent. And for the subcomponent assemblies, you can have, the BOM for each subcomponent, okay, and then all the things needed to build those. Now, the only thing that is missing here compared to something like this, and actually I have it here, is you have some of these assembly pieces. So where's your and semiconductor we call it FIF, first in fab kit. So where's your kind of parts needed to build the system, the hardware and things like that. So sometimes people don't put it inside the model. Another option that you have is you can go in and kind of make things non-geometric generally. So um, I've never actually tried to do that here inside of Fusion. I do that at work, but maybe. So there's probably a way in here to kind of make it non-geometric so it shows up inside the model when you export the BOM, but it doesn't actually, it's not visible, right? I'm gonna have to look up what it's called, but in NX at work it's called non-geometric, which is it's there inside the CAD, but you can't actually see it, but you'll see it in the hierarchy here. Anyways, so have the first in fab kits, the Allen wrenches, all these things in there, and so this makes it easier than an Excel spreadsheet because this guy is constantly updated. And then if you decide to create a new spreadsheet, you could forget it in the spreadsheet. Generally, everything is built off of the model, so it's great to have it into the model. Another thing that you can do if you have it in the model is you pop it in and out of geometric and check installation. So it's like, hey, I have this Allen wrench. Okay, I'm going to install this screw or a screw inside or something at some point for your assembly. Also, it makes it easier to do a virtual assembly sequence, to do a rendered assembly sequence, and to have the Allen wrench that you're actually going to give physically modeled, and show that, hey, if you install it here, you're not going to have any sort of interference of it hitting a wall, or it's actually physically installable. So that also helps to have, and also to show yourself like, hey, if I get a McMaster Allen wrench, oh, this one actually doesn't work. So I need to have a special ground down Allen wrench for this installation. Or what am I going to provide with the kit, or what am I going to recommend to have in the kit? So that way you can have that in as non-geometric, and you can use it for these different types of documents that you want to put together. Renderings or animations or anything like that, assembly sequence, any sort of documents, whatever. So that would be cool to have. I'm not exactly sure how to do it in Fusion. I never tried. I do it all the time at work. Don't do it on the other things that I do, but that would be a good thing to find out, because that would be great to have some sort of tool. Basically, First Fab is like a tool kit that you have in here that is geometric, that is non-geometric. And then also in NX they have another option. So the two options they have: non-geometric. The second one is reference. So reference means that it is there physically, you can physically see it, but when you export a BOM, it doesn't show up on the BOM. When you export it, it omits that export. So I'm not sure if that's another Fusion option. So that's another thing to do if, hey, I want to have it in the CAD model, but I don't want to have it in my BOM. I'm doing a kit, and the user is going to have to supply all their tools. Or the tool is just there so I can easily use it to create these animations in assembly sequences, but I do not want to have it ordered for all the systems that I'm building, because I'm building it in-house. So we have our own tooling in-house, and I just want to make sure that the tooling that we're going to get and the list of the tooling that I'm going to give them is separated. So that's another way to do it. Another option is you can just put that in a sub-component and then make the sub-component reference or not reference. So when you export the system, if you do a change to the tooling kit, the tooling that will be captured, and then if you want to omit it, you just delete the tooling kit. So you can have a special naming convention to make sure that you don't make mistakes with that. So there's all different types of things that you can do there. Again, also another thing with non-geometric is you can just hide it. Obviously, it's another thing you can do. But when you go in here and you show all components, it's going to show up again, and you got to hide it again. So it'd be nice that if you show all the components, that that one actually doesn't hide. So anyways, I'll figure out how to do that kind of non-reference and geometric and also reference. Anyways, B plus, A minus for the assembly here. I would say maybe even up to an A. Overall, just very, very good. So very good assembly, very good documentation. The assembly and the hierarchy follow the documentation. It's very well compact. I don't, obviously besides banana, I don't see any other way that you would make this any more compact. The only thing that people would think of is, oh, what about the top hat? But the reason why I think the top hat is like that is so they can actually have an animation of that top hat moving. And so that's why they have it segmented that way. Overall, I would say this is a great system to reference with your own designs, mechanical designs. Okay, let's go ahead and move on. School group, hardware development school groups in the description. Go ahead and check that out. And let's go ahead and move on to the next video.